To calculate the demand load for a backup generator, consider these steps. Firstly, determine the voltage of the electrical system. For example, assume a 240-volt system is being used. Secondly, calculate the maximum current that the breaker can handle. Maximum current is equal to the breaker amperage multiplied by the voltage. Using the example of a 70 amps breaker and 240 volt system, a maximum current is 70 amps multiplied by 240 volts, which equals 16,800 watts. Thirdly, determine the generator's load capacity. The generator's load capacity is rated at 15 kilowatts, which is equal to 15 kilowatts multiplied by 1000, resulting in 15,000 watts. Fourthly, check if the generator can handle the load. To do this, compare the demand load to the generator's load capacity. In this example, the demand load is 16,800 watts, which exceeds the generator's load capacity of 15,000 watts. Therefore, in this instance, the generator cannot fully support the electrical demands. Several recommendations can be considered. 1. Reduce the electrical load. Identify essential appliances and devices that can be temporarily disconnected to reduce the demand load. 2. Install a smaller generator. Consider installing a generator with a higher output capacity to meet the electrical demands. 3. Use a more efficient generator. Select a generator with a higher power factor to maximize its output and reduce the demand load. 4. Use a load shedding device. This device can automatically disconnect non-essential loads to prevent overloading the generator. Consider these additional notes. The maximum current calculated assumes that all 70 amps of the breaker are being utilized. In practice, some reserve capacity may be available. The generator's load capacity may be affected by altitude and temperature. It is recommended to consult with a qualified electrician for proper sizing and installation of a backup generator.